Hello students, welcome to my channel. In this class, I am going to teach you improper integrals. So let us solve some problems from improper integral. Now the first question is, show that the gamma function gamma of n is equal to 0 to infinity x to the power n minus 1 e to the power minus x dx is convergent if and only if n greater than 0. So in order to prove this, let f of x is equal to x to the power n minus 1 e to the power minus x. Here, when n less than 1, then 0 is a point of infinite discontinuity of f of x. So when n less than 1, then 0. When n less than 1, then 0 is the point of infinite discontinuity of the function f of x. So we have to test the convergence at a 0 and a infinity. Let gamma of n 0 to infinity x to the power n minus 1 e to the power minus x dx is equal to 0 to 1 x to the power n minus 1 e to the power minus x dx plus 1 to infinity x to the power n minus 1 e to the power minus x dx. So let us take this integral I1 plus I2. So we are taking 1 is the intermediate point between 0 and a infinity. To test the convergence at a 0. So let us test the convergence at 0. Let n less than 1 and phi of x 1 by x to the power 1 minus n. Now limit extending to 0 fx by phi of x is equal to limit extending to 0. The value of fx is x to the power n minus 1 e to the power minus x by phi x is 1 by x to the power 1 minus n. So this is equals to limit extending to 0 x to the power n minus 1 minus plus 1 minus n e to the power minus x. So this is equals to limit extending to 0 x to the power 0 e to the power minus x This is limit extending to 0, 1 e to the power minus x. Limit extending to 0, e to the power minus x is equal to 1. So, limit extending to 0 fx by phi x is 1. Here, integration 0 to 1 phi x dx is equal to 0 to 1. 1 by x to the power 1 by n dx. Convergent if 1 minus n less than 1 implies n greater than 0. Now convergence at infinity. Given n, we have e to the power x greater than x to the power n plus 1 for sufficiently large value of x. So convergence at infinity. Given n, we have e to the power x greater than x to the power n plus 1 for a sufficiently large value of x. So this implies 1 by e to the power x less than 1 by x to the power n plus 1. So this implies e to the power minus x less than x to the power n plus 1. This implies x to the power n minus 1 into e to the power minus x less than x to the power n minus 1 by x to the power n plus 1. So this implies x to the power n minus 1 e to the power minus x less than x to the power n minus 1 into x to the power minus n minus 1. So this is plus 1. So this implies x to the power n minus 1 e to the power minus n x to the power minus 2 implies x to the power n minus 1 e to the power minus x less than 1 by x square. Now integration from 1 to infinity 1 by x square dx is convergent as n is equal to 2 greater than 1. So integration 1 to infinity x to the power n minus 1 e to the power minus x dx is also convergent by comparison test. Hence, gamma for a 0 to infinity x to the power n minus 1 e to the power minus x dx is convergent if n greater than 0. So we proved the gamma function is convergent if and only if n greater than 0. Now let us proceed to solve another problem. So our second problem is so that integration 0 to infinity 1 by 1 plus x minus e to the power minus x dx by x is convergent. Proof. Let fx is equal to 1 by 1 plus x 1 by x. So this is equal to 1 by 1 plus x 1 by e to the power x into 1 by x. So this is equals to this is e to the power x minus 1 minus x by 1 plus x e to the power x into x. So which is greater than 0 for all x greater than. Let integration 0 to infinity 1 by 1 plus x minus x dx by x is equal to 0 to 1 integration e to the power x minus 1 minus x by 1 plus x into x e to the power x dx plus integration 1 to infinity e to the power x minus 1 minus x by 1 plus x into e to the power x. So let us take this one I1 and this is I2. Now I1 which is equals to integration 0 to 1 e to the power x minus 1 minus x by 1 plus x into x e to the power x dx. This integral is a proper integral. As it has no discontinuity at a x is equal to 0. When x tends to 0, then fx tends to 0 here. So the integral is a proper integral. It has no discontinuity at x is equal to 0. When x tends to 0, then f of x tends to 0. So I1 convergent integral. Again, I2, which is equal to integration 1 to infinity e to the power minus 1 e to the power x minus 1 minus x by 1 plus x into e to the power x dx. Let phi of x is equal to 1 by x square. Now limit extending to infinity fx by phi of x is equal to limit extends to infinity e to the power x minus 1 minus x by 1 plus x into x e to the power x divided by 1 by x square. Then that is equals to limit extending to infinity e to the power x minus 1 plus x by e to the power x into 1 by x into 1 plus x, here x square. So this is equals to limit extending to infinity e to the power x minus 1 plus x by e to the power x, and this is equals to x by 1 plus x. Now limit extending to infinity 1 minus 1 plus x by e to the power x. This is x by 1 plus x, which is equals to limit extending to infinity 1 minus 1 plus x by e to the power x. This is 1 by 1 plus x into 1. So this is equal to 1 minus 0, 1 by 0 plus 1, which is equal to 1. Phi of x, this is 1 to infinity 1 by x square dx is convergent as n is equal to 2 greater than 1. So 1 to infinity 1 by 1 plus x e to the power minus x dx by x is convergent. By comparison test limit form. So convergent by comparison test limit form, hence integration 0 to infinity 1 by 1 plus x e to the power minus x dx by x is convergent. Proved. So the second problem is now completed. The topic for today class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.